I'm going to show you how to calculate something called molar mass and percent composition. Y'all, these are super easy, really straightforward. I just want to show you examples. I'm actually going to use a harder example. That way you can do the easier examples in addition to the harder ones. But when I'm talking about molar mass, this is how much the compound weighs, specifically 1 mole of it. And when we start stoichiometry, that's our next lesson, then we will talk about what the mole means. But basically, how much does this weigh? So we have to take into account a few things. One, we're going to build this little table here. And so when I ask for you to show me work, this is what I'm going to ask for when you turn in assignments. But this first column, this is how many atoms there are of each of the separate elements. So if we look in this compound, obviously calcium, phosphorus, and oxygen, they all weigh different things. That's why we're splitting them up here. This is how many atoms there are. So we look at subscripts. For calcium, there are 3 of them. So now, I did one with parentheses just to be wary of the fact that some of you are still struggling to distribute. But remember, this 2 belongs to everybody inside of the parentheses, right? So just like balancing. So this 2, we multiply it to phosphorus. There are 2 phosphorus atoms. 2 times 4 oxygen, there are 8 oxygen atoms. So now we need to go look at how much each of these calcium, each of these phosphorus, and each of these oxygen weighs. And that is where we look at our beautiful periodic table. So if we look at calcium, we're gonna round to the nearest whole number. Let's make this easy. So calcium, 40.078, we're gonna round it to 40. Phosphorus, we look here. Again, rounding to the nearest whole number. Also, my nails are done. Y'all better not make fun of me. Okay, so phosphorus, it'd be 30.97. So we're going to round it to 31. Remember, if that first place after the decimal is 5 or greater, we round up. And then if it's less than 5, we round down. Even if this is 0.49, we still round down. So now, and yes, I have a glass table. So, oh my gosh, of course, this is going to erase. Okay, so now, this oxygen, we look, and it's 16. So now, I want you to think about this logically. You have 3 atoms. They each weigh 40. What are we going to do? We're going to multiply these columns. 3 times 140. So the calcium, this is how many grams it would weigh. 2 times 31, 62. And then this, 128. So now this is how much each of the parts weigh. We want to know how much the whole compound weighs. We're going to add together this last column. So this 8, 9, 10, 310. And the unit we're going to use is grams per mole. This is the molar mass of the compound. So now let's look at percent composition. Y'all, you do this kind of math all the time. If I have a whole pizza and I eat 4 of the 8 slices, that is 50%. That's exactly what we're calculating here. Except this is in terms of compounds, right? Of elements. So, looking at this example here, we know our whole compound weighs 310 grams. If I wanted to know the percent composition of each of the elements here, so here we have calcium, phosphorus, and oxygen. If I wanted to know what percentage of this whole compound was just calcium, if I want to know what percentage was just phosphorus, just oxygen, I'm going to look at the part they contribute to the whole thing. So this is a fraction that we're going to convert to a percentage. Okay? So, easy peasy lemon squeezy. Part we're concerned about. Make sure you're using this column. There are 3 calciums, not just 1, so don't put 40. You would put this column. So you have 120 divided by how much the whole thing weighs. By the way, you should start to be able to make predictions. So like for me, I know that oxygen is going to contribute the highest percentage. This would be the least percentage. And I also know things like this percentage should be half of this percentage. Again, number sense, right? That's what we want to practice. I never want you to memorize something. I want you to understand why you're calculating it. Okay, so 120 divided by 310 times 100. Then we see here phosphorus, 62 divided by 310 times 100. Oxygen, 128 divided by 310 times 100. Okay, Okay, so now another thing that we need to consider is we already know that this column right here should equal 100%, right? Hold on. So now, when we look at calculating this, we're going to put 120 divided by 310, okay, times 100, or I personally just moved the decimal twice, but 38.7%. And we will round to the nearest 10%. So again, this percentage, just looking at the fraction, this one should be about half of this percentage, but let's just do it. Oop, sorry. $20. Weird. Almost half. Do you see how this is starting to make sense? Okay, next. 128 divided by 310. Before I even put this in the calculator, I know that this percentage should be higher than this percentage because I see that 120, this one's 128 times 100, or I can move it twice, 41.3%, which makes sense. If I add this all together, I have 100% of the compound.